Okey, Assalamualaikum semua. Assalamualaikum. Dengar tak?
Dengar. Waalaikumsalam.
Okey.
Soalan doktor.
Okey, so semua dah sarapan ke?
Sudah doktor, sudah.
Semua dah sarapan?
Dah.
Belum.
Okey. Belum? Kenapa? Sambil-sambil kelas tu boleh makan Okey? Okay, so for BSK2143, okay, before I start with the description of this course, I want to introduce myself. My name is Dr. Nurlin Abu Sama, and some of you I already saya ajar SEM lepas, okay, analytical chemistry. Dan saya boleh aware lah siapa dia. Okay, for this yang masih tak kenal saya tu, okay, nama saya Dr. Nurlin Abu Sama. Okay. Okay, so now we have our all of the student dah masuk Okay. Okay, so boleh nampak slide tak? Boleh nampak apa yang saya appear tak?
Nampak.
Nampak Okay. Okay, so now for BSK2143, this is the subject of the name of the subject is instrumentation method. Okay, so this is the course extended to analytical chemistry. Okay, so who are going to teach you for this semester? It's me, Dr. Nurlin Awsama, and another lecturer is Associate Prof. Dr. Hazrul Rizawati Abdul Hamid. Okay, so let's check for our timetable. Our class will be today, Tuesday, 10 a.m. until 11 a.m. Okay, and Thursday, 9 a.m. until 11 p.m. Okay, so for those yang ada problem dengan jadual clash ke apa ke, please let me know and faculty knows as soon as possible. Okay. Okay, now let's look for the course synopsis. What you're going to learn in this course, okay? This course is designed to introduce the modern instrumental methods, okay? I believe that during by the time you take you go for the analytical chemistry class, all of the knowledge is about the classical method, like more towards titration. Okay, so this is the extended, okay, the extended of from the analytical chemistry. Okay, so in order to solve problems in analytical chemistry, you need more advanced compared to the classical method. So this is the one thing that you should know, that by the time you're going to the third year, fourth year, you will learn a lot about more advanced, okay, more advanced technique. Okay, so all of that is to make our analysis become simple and accurate. Okay, so that is the purpose. Okay, so a qualitative and quantitative analysis, I believe that most of you know the definition of qualitative and quantitative analysis. So in order for you to understand this course, you must have a knowledge about analytical chemistry. Okay. Next, the course will begin with the explanation of instrumentation methods, concept, and the tools of quantitative analysis. So what you're going to learn from this course is actually how you can develop one technique or one instrument, okay, based on a concept. Okay, so you must know what is the concept, and then you can make one instrument. Okay. Okay, next, student will be exposed to a different instruments. Okay, so like AAS, atomic absorption spectrometer, UVV spectrophotometer. I believe that most of you already hands-on UVV spectrophotometer. But in this course, you will learn a lot about that instrument, not analysis. Okay, so what is the main thing in this instrument? Okay, like a schematic diagram of the instrument. Okay, okay. FTIR is the Fourier transform infrared. Okay, so you can see that UVVs is the what we can see is that the difference is the source of the light. Okay, like UVVs, they use ultraviolet and visible light. Okay, for the FPIR, they use the infrared. Okay, infrared ray. Okay, next is we have a mass spec. Okay, mass spectrometer. Okay, so you will understand more about the most of it spectrophotometer. Okay. Okay. Next is GC. GC is gas chromatography, and next is HPLC. You will learn about the high performance liquid chromatography. I see the inductive couple plasma. Okay, but I think that there will be one part covered by Dr. Hazrul. And the last one is NMR, nuclear magnetic resonance. Okay, so why we have lots of instruments? Because we have different kinds of problem to analyze. Okay, so here we can see that if you want to detect your analyte, okay, your analyte is like heavy metals. Okay, so you need to choose the right instrument to analyze your sample. That is the one thing that you should know. Okay, in order to investigate your sample. Okay. Okay, class. If you cannot see, let me know. Jangan senyap je. Boleh? Hello.
Boleh.
Okay.
Boleh.
Okay, now let's look for the CO, the course outcome. Okay, the first course outcome is to demonstrate knowledge of instrumental analysis principle. So basically, you will be exposed with the concept of instrumentation. Okay, so how the instruments are set up based on what concept. That is what you will learn in this course. Okay. Next, the course outcome number 2. Select the most appropriate instrumental analysis technique to solve an analytical problem. Okay, so this is what I mean just now, that you need to choose the right instrument for the right problem. Okay, so in order if you want to solve any kinds of problem, you need to know what is the best method. Okay, you should know this. Okay, and the third course outcome is able to discuss new application in instrumental analysis. Okay, so you should um, mm, you should be able to discuss about this instrument, okay, without any help from the lecturers. Okay. Okay, so this is the list of topics that will be covered in this course. Okay, we have about 9 chapters. So the first chapters until chapter 5, okay, from the introduction of instrumentation method until mass spectrometer, will be covered by me. And from chapter 6 onwards, okay, will be covered by Associate Prof. Dr. Hazrul Rizawati. Okay. Okay, so this is the assessment method and the mark distribution. So you can see we have one test covered 20%. We have 5 quizzes covered 20%, one assignment covered 20%, and final exam covered 40%. And this mark distribution will be depends on the UMP management, okay, decision, because we as you know that the last semester the distribution is different, like cover about 80% of carry mark and 20% for final exam. Okay, so you need to be ready. Okay, what I can advise here is that please do well in all assessment, because if you get less or very low mark in carry mark, it will affect the your mark in the final exam. So what I can advise here, please do all the assessment, and if you cannot understand or you want you want um, or if kalau kamu perlu kebantuan, you can ask me directly, okay, via WhatsApp, okay. So that's all for the assessment mark distribution, okay. So when will be the assessment you need to take, okay. So this is the table that explain about your assessment, and just be ready for each assessment, okay. And I believe that all the assessment will be online, okay. So I hope that you all ready, and I think that the question will be tougher, but as you all know that you need to be ready, because online is the question is getting online assessment is a bit tricky, okay. So just be ready. Okay, so I just want to let you know that for this semester, you only have about 13 weeks. Okay, just like previous one, we have 14 weeks, but this time we have only 13 weeks. Okay, so please take note so that you will not miss any assessment. Okay. Okay, so that's all for the introduction of BSK2143. Any question from you? Do you have any question?
No.
No? Okay. Sorry, saya clear tak? Clear
Clear.
Okay. Okay, sesiapa yang kalau ada masalah berkenaan dengan internet, saya advise untuk kamu inform saya awal supaya supaya tak ada yang tertinggal lah. Saya kalau boleh semua saya nak dapat sama rata. Boleh Okay, untuk part saya, the method of teaching is actually melalui video yang kita rakam macam ni. Do you agree? Setuju ke?
Yes.
Farah? Okay. So saya rasa benda ni pun, subjek ni dia more kepada penerangan berkenaan dengan alat. Jadi kalau macam video tu saya tak berapa macam cakap saya tak berapa nak saya lebih suka two ways lah, okay, two ways communication, okay. Okay, now let's look for the list, the name list of students. Boleh nampak tak?
Boleh.
Boleh nampak Okay, ada tak nama yang tak ada? Kalau ada sesiapa yang nama tak ada kat dalam ni, nanti tolong update kat saya. The problem, better kita aware problem berkenaan dengan registration ni dari awal. So that tak adalah kalau awak dah awak ikut kelas tapi nama awak tak ada, bila final exam tak boleh duduk, tak boleh sit for the exam. That is the effect if you not aware of the registration. Okay, so I hope that all of you already register your name. Okay. Okay. So now I will give the list, the Google form for your attendance. Okay. Okay, please check your WhatsApp and fill in that form. Okay, for your attendance. Okay. Okay, so yang saya perasan Azaim, Aiman, siapa lagi? Okay. Yang saya cam lah, Zulfa, siapa lagi? Tengku Amalia, Wirda, Wan Nurafika. Yang ni yang ambil subjek analytical chemistry sem lepas kan? Nama yang saya kan, okay. Okay, so pasal itu tak ada yang fail, Alhamdulillah. Okay. Okay, so now we are going to start with our chapter 1. Okay, so this is our first chapter. This is just an introduction. So we just it's just for refreshment from the analytical chemistry. Okay, so in the course description, you will learn about 3 different lines, but not all. We focus on the spectrochemical analysis and also chromatographic analysis. Okay, so basically you will have a basic knowledge of different kinds of instrument. Okay, like AAS, UVVs, IR, okay, NMR, mass spec. Okay, for the chromatographic analysis, we have 2 main chromatographic technique, which is liquid chromatography and gas chromatography. Okay, for the electrochemical analysis, we have a potentiometry and also voltammetry. Okay, so the reference book that you can search is Scoop. Okay, the title is Principles of Instrumental Analysis. Okay. Okay. So basically, when we try to understand what is analytical chemistry, okay, we trying to analyze our sample. Okay, so in order to analyze our sample, we need to understand there are two different kinds of analysis. Okay, the first one is qualitative analysis, and the second one is quantitative analysis. Okay, so I hope that you are aware of the terms called analytes or analyte. Okay, this term is very important because in analytical chemistry we always use this as the normal term. Okay, we always talk about analytes. Okay, okay. So basically, we want to identify what is the analyte. Okay, so basically, when we have these two different kinds of analysis, okay, siapa yang tahu qualitative analysis tu contoh macam mana? Any answer? Qualitative analysis. Ada siapa tahu tak? Benda ni you all dah belajar masa tahun 1. Tak tahu ke? Okay, qualitative analysis ni lebih kurang macam give you the answer yes or no without a number, okay, without a value. Like macam contoh macam acid base ataupun litmus paper. Okay, it tells you about the either it is acid or base. Okay, so this is one example of a qualitative analysis. Okay, it tells you yes or no. Okay, without telling you about the value. But different with quantitative analysis. Quantitative analysis, we explain about the how much the content of your analyte in the sample. That is quantitative analysis. Okay. Okay, so analyte, the species to be determined in the sample. Okay, as you all know that we have different kinds of problem to be analyzed. Okay, so when you have a different sample, of course, you will have different types of analyte. Okay. Okay, so a matrix is all of the components in the sample, including analytes. Okay, that is what we call as matrix. Okay. Okay, so now let's look for the classical method. Okay, so qualitative is you can identify by color changes. Okay, indicator. Okay, boiling or melting points or orders. Okay, so this is something that tells you about like something that have a big error. Okay, basically. But when let's look for the quantitative, it is a more accurate analysis, and basically this analysis is refer to different kinds of parameter, like for mass or volume. Okay, for example, dalam in gravimetric analysis, okay, you will focus on the mass of the precipitate form at the end after the titration. That is what we call quantitative analysis. Okay, you will weight the mass of the precipitate. And next is volume, like volumetric. Okay, so you do a simple titration and then you measure the titrant volume. Okay, so this is what we call as quantitative analysis. Okay. So next is instrumental methods. So here, this is the one thing that we will focus on in this course. So also we have a qualitative and quantitative analysis. Okay. So basically, qualitative we can identify from the instrument like chromatography. We can identify either the peak is there. I mean, we can estimate either our analyte is there. Okay. That is what we the meaning of qualitative analysis in instrumental methods. Okay. For the quantitative analysis, we measure the concentration, and then we uh, analyze the results. Okay. Okay, so here we have different kinds of signal for instrumental methods. Okay, so basically we have emission and absorption. So basically when we talk about absorption, I start with emission. Okay, so when we talk about emission, we are referred to the something that emit, okay, emit from the analysis. Okay, so this is what we call emission spectroscopy. Okay, so basically the types of spectroscopy is like X-ray, UV-Vis. Okay, so this is what we can uh, understand from the emission. Okay, and other than that, like fluorescence, phosphorescence, okay, luminescence, okay, this give you a glow in the dark color, like it gives you something that it emits the light, okay, from the sample, okay. And the next one is the absorption. So in absorption, we are talking about the same method, but we will focus on this in the next chapter about the spectroscopy. Okay, and we also have the electron spin resonance here. Okay. Okay, so other than that, we also have scattering, refraction, diffraction, rotation, and also the electrical potential. Okay, so this is the few examples of the signal. Okay. Okay, also we have electrical charge, electrical current, okay, mass, okay, mass to charge ratio. This is the signal for the mass spectrometry. Okay. Okay, so for the instruments, okay, we can convert the information stored in the physical or chemical characteristic of the analyte into useful information. This is the concept. When we talk about uh, the instrument technique, we are actually trying to convert, okay, the information that stored in the analyte, okay, either it is a physical or chemical characteristic, into useful information. Okay, so you can identify this useful information as your output from the instrument. Okay, and next is require a source of energy to stimulate measurable response from analyte. So basically, most of the instrument that you will learn in this course, they have the source of light, source of energy. Okay, so basically, when we talk about the source of energy, like UV spectrophotometer, they use UV light and visible light as the source of energy. Okay, like FTIR, Fourier transform infrared, they use infrared as the source of energy. Okay, so what I want to explain here is that most of the instrument require a source of energy. Okay, okay, to stimulate the measurable response. Okay, from the analytes. Okay. So the basic concept of analysis by using instrumental method is that we have the energy, okay, the source of energy, and then it passing through the analytes in a matrix, okay. Still remember matrix? Maksudnya sample tu termasuk dengan analytes. That is what we call as matrix. Okay, and then dia pergi kepada analytical response. Okay, so this analytical response will be changed encoded information as a data. Okay, like macam UV spectrophotometer, you will get the value, right? Okay, the value of the absorption. Okay, so what we can identify here that the output is what we call as a spectrum, okay, from the UV V's spectrophotometer. Okay, so like for this example of spectrophotometry, okay, so the instrument is called spectrophotometer. Okay, jangan confuse with spectrophotometry dan spectrophotometer. Instrumen kita panggil sebagai spectrophotometer, tapi method kita panggil sebagai spectrophotometry. Okay, so this is two things, different things walaupun ending dia tu lain, metri dan meter. Okay. Okay, the stimulus energy is the monochromatic light energy. Okay. Analytical response is the photocell. Okay. Data, the electric current, okay, that passing through the the electrical current that get from the analytical response. Data processor is the current meter, okay, and readout is the meter scale. Okay, so what is a detector? Detector is the device that indicates a change in one variable in its environment. Okay, for example, pressure, temperature, particles. Okay, so basically this detector can detect, okay, can detect your analytes, okay, by depending on one variables or one parameter changes. Okay, so this is the one thing that you must understand. Okay, in order for you to develop the the sorry the instrument. Okay, okay. So for the detector, it can be mechanical, electrical, or chemical detector. Okay. Okay, sensor. Sensor is the device that converts chemical to electrical data. So from this definition, you can see that from the chemical, it changed to electrical data. And basically, electrical data is the current that they try to measure. Okay. And we also have a transducer. So this device convert non-electrical domains to electrical data. Okay, so this is the non-electrical domains. Okay, like the physical properties. Okay, like light intensity, color. Okay, so this is the electrical domain is the current, and you can see the other of non-electrical domains. Okay, so now let's look. Okay, what is the how we can select the best analytical method. Okay, so basically you need to have a question, okay, in order for you to solve your problem. Okay, like for the first question is how to choose analytical method, and then how good is measurement. Okay, so when we talk about how good is measurement, we always refer to how accurate your analysis. Okay, how precise is your analysis. Okay, that is the parameter that can tells you whether your measurement is good or not. Okay, and you can see also here how reproducible the precision. Okay, how close to true value. So this is the accuracy. I hope that you can still remember the definition of precision and accuracy. Okay. Next, how small a difference can be measured. Okay. So if the instrument is can detect a very small amount of your analytes, we can estimate that the instrument is very sensitive. Okay, towards your analytes. Okay. And what range of amounts? Okay, so next is how much interference. Okay, so when you have many kinds of interference, okay, so but the instrument can select your analytes at a high percentage of recovery. So it means that the analytical method is very selective. Okay. Okay, so here we have the explanation of precision. Okay, the precision, or we call as random errors. Okay, so basically we will use like standard deviation. I hope that all of you can recall the formula that you use to calculate standard deviation, or you can simply use the calculator to determine the standard deviation. Okay, RSD, variance, CV, coefficient of variation. Okay, and this is the things that must be included in the random errors. Okay, so this is the formula, okay, that we can use to calculate the different parameters of in the random errors. Okay. Okay, now let's look for the accuracy. To this accuracy is focusing on the determinate errors. Okay. For the determinate errors, we are focusing on the operator method and also instrumental. Okay. So you can see this is a very good example of difference between accuracy and precision. Okay. I hope that you can still remember the percent relative error formula. Okay. Okay, now for the sensitivity, the ability to detect qualitative analysis, okay, and determine the small amount of analyte in the sample. Okay, so just like what I mentioned just now about the sensitivity, okay, if the instrument or analytical method can detect the very tiny or very trace amount of your analytes, we can estimate that instrument is very sensitive. Okay. Okay, so here is the detection limit. Okay, what is the detection limit? Okay, the lowest concentration of analyte in a sample can be detected. Okay, so detection limit ni samalah dengan LOD. Okay, limit of detection. Okay. Okay, dynamic range. Okay, range is very important because range is the linearity. The range is the linear. The linear. The data that give you a linear slope. Okay, so in this linear slope, it gives you the significance of value. Okay, so you can see from this calibration curve. Okay, so saya harap you all tahu calibration curve. Okay, calibration curve ni apa tujuan yang kita buat. That is the thing that you need to know before you can understand each point in the calibration curve. Okay. Okay, so here you can see we have LOD, we have LOQ, and we have LOL. Okay, so LOD is the limit of detection. Okay, LOQ is the limit of quantification, and LOL is the limit of linearity. Okay, so you can see that the linear path here, starting from the LOQ until LOL, this path is the dynamic range. Okay, this dynamic range will be different even though you use the same instrument. Okay, but the sample is different. The range will be different. The dynamic range will be different, but it depends also on your analytes. Okay. Okay, selectivity. This is the method that I mentioned to you, that the ability of method to measure one species to be selective. Okay, one species of the analyte in the presence of other elements of compound. In the other presence of other elements ni, kita refer kepada interference, the disturbance. Okay? So you can see that signal is always the sum of calibration sensitivity, okay, and the concentration of your analyte. Okay. Okay, so calibration methods, basically we will refer to the quantitative analysis. Okay, we always refer to the linear slope. Okay, so what we can estimate from the linear slope is that the signal must be direct proportional to the analyte concentration. Okay, so this is the idea on preparing the calibration methods. So this is the example, okay, of calculation. Okay, I believe that pada yang baru habis exam hari tu, okay, ada soalan macam ni So untuk analytical chemistry, okay. This is the classical method on how to calculate the like standard deviation, okay, variance, okay, and slope. How you need to know how to calculate the slope, okay, and also the intercept, okay. So overall, the calibration curve will we will follow the y equals to mx plus c. Okay, this is y equals to mx plus c is actually the linear expression, okay, that represent the linear slope. Okay. Okay, so I think that's all for today. Okay, do you have any question? Ada apa-apa soalan tak? Nak tanya? Okay. Ya? Saya upload dalam kalam. Yang video ni, yang video kita setiap kali kelas, saya akan bagi melalui WhatsApp. Ke korang lagi prefer kalam? Which one? Ke saya upload dekat kalam jugalah?
Kalam je.
At the same time saya bagi link juga dekat WhatsApp Boleh?
Boleh?
Boleh.
Boleh Doktor.
Okay. Ada apa-apa lagi soalan tak? Saya rasa macam nak tamatkan kelas untuk hari ni. So kalau tak ada apa-apa soalan, kalau ada apa-apa soalan lah, you can WhatsApp, okay? Saya rasa dah clear kan tadi explanation saya berkenaan dengan assessment, everything, okay? Okay, so saya rasa sampai di sini saja kelas kita untuk hari ini. And then saya harap kamu boleh participate dalam setiap kelas kita, okay? And I hope that we will have a two-way of communication, because if it's only me to explain, and then it's very difficult for me to identify either you understand or not. Okay, so it's very important for me. Okay, boleh Kalau tak boleh. Okay, kalau tak macam you nak tanya soalan tapi you tak nak cakap, it's okay, you can type dekat chat je. Saya akan baca. Boleh
Boleh.
Boleh.
Okay. So that's all for today. Saya akan upload nota dalam kalam dan saya akan bagi Google Meet record ni dekat WhatsApp dan kalam. Okay, so you can refer directly there. Okay. Okay, thank you class. Okay.
Okay, thank you,
Okay,
Doktor.
see you.
Thank you, Doktor.
See you.